Where is everybody? This is the fundamental question that physicist Enrico Fermi asked when pondering the vastness of the universe. Given the sheer number of stars and planets out there, it seems statistically improbable that we are alone. Yet, we haven't encountered a single shred of credible evidence to suggest otherwise. This is the Fermi Paradox. In this video, we explore 5 unsettling solutions to the Fermi Paradox and attempt to provide insights into why we might be so alone in the universe. The first possibility we'll consider is a rather sobering one: the Great Filter. This theory posits that somewhere on the long, winding road from inanimate matter to a thriving, spacefaring civilization, there's a wall. Not a literal wall, mind you, but a metaphorical one. A challenge so difficult, so improbable to overcome, that it acts as a bottleneck for life in the universe. Think of it like this. Imagine a million grains of sand, each representing a planet with the potential for life. Now, imagine that to become a spacefaring civilization, life on that planet has to pass through a series of ever-narrowing funnels. Each funnel represents a critical step in evolution: the emergence of life, the development of complex cells, the rise of intelligence, and finally the technological advancement needed for interstellar travel. The Great Filter could be any one of these funnels, or perhaps a combination of several. Maybe the spontaneous generation of life from non-living matter is exceedingly rare. Perhaps the evolution of intelligence is an incredibly improbable event. Or maybe, just maybe, the filter lies ahead of us. Perhaps there's some inherent danger in technological advancement that inevitably leads to self-destruction before a civilization can reach for the stars. The chilling implication of the Great Filter is that if it exists, we've obviously overcome it. We're here, aren't we? But the lack of other intelligent life suggests that it's a hurdle most civilizations don't clear. And that begs the question, what insurmountable obstacle did we as humans manage to overcome while countless others faltered? The zoo hypothesis offers a more intriguing, if somewhat unsettling, explanation for the Fermi paradox. It suggests that we're not alone, but rather that we're being kept in the dark, intentionally. Imagine, if you will, that the Milky Way galaxy is a vast cosmic zoo and Earth is just one exhibit among many. The idea here is that advanced extraterrestrial civilizations are aware of our presence. They know we're here, they're watching us, but they're choosing not to interfere. They're like cosmic anthropologists, observing us from a distance, studying our development without directly intervening in our affairs. Think of it this way: if you came across an anthill in the forest, would you go marching in, announcing your presence and disrupting their way of life? Or would you observe them from a distance, fascinated by their complex society and intricate network of tunnels? Proponents of the zoo hypothesis argue that advanced civilizations might be doing the same to us. They might have established a kind of prime directive, similar to the one from Star Trek, that forbids them from interfering with less developed civilizations. They might be waiting for us to reach a certain level of technological or social maturity before they make contact, or perhaps they're simply content to observe us from the shadows, curious about our species but unwilling to risk contaminating our culture or influencing our development. It's a bit like watching a nature documentary, except in this case, we're the ones being observed. If the zoo hypothesis is true, then we're not alone, but we're also not in control. We're like children in a cosmic playground being watched over by unseen caretakers. It's a humbling thought, to be sure, but also a hopeful one. Chapter 3: Self-Destruction. Perhaps the most unsettling explanation for the Fermi paradox is the possibility that we're not hearing from other civilizations because they've already destroyed themselves. This is the self-destruction hypothesis, and it suggests that intelligence might be a self-limiting phenomenon. The idea here is that as civilizations advance technologically, they inevitably develop the means to destroy themselves, whether through nuclear war, environmental devastation, or some other unforeseen consequence of unchecked technological progress. It's a sobering thought, but one that's all too plausible given our own history of conflict and our seemingly insatiable appetite for resources. Think about it. We've only been a technologically advanced civilization for a few hundred years, and in that short time we've already invented nuclear weapons, developed the capacity to pollute our planet on a global scale, and created artificial intelligence that could potentially surpass our own. It's not hard to imagine that other civilizations might have followed a similar trajectory, developing the means to destroy themselves long before they were able to solve the challenges of interstellar travel or establish a lasting presence in the galaxy. Perhaps the reason we haven't encountered any other civilizations is that they simply didn't last long enough to make contact. The self-destruction hypothesis is a stark reminder that intelligence is not a guarantee of survival. In fact, it might be the very thing that dooms us. If we're not careful, our own ingenuity could be our undoing. We have the power to shape our own destiny, but we also have the power to destroy ourselves. Chapter 4. We're not looking in the right way. The vastness of space is almost incomprehensible to the human mind. Light, the fastest thing we know of, takes years to reach us from even the nearest stars. So when we talk about searching for extraterrestrial intelligence, we're talking about searching for signals that have traveled potentially thousands, millions, even billions of years to reach us. What if we're simply not tuned to the right channels? What if our methods of listening are akin to searching for a whisper in a hurricane? We've spent decades scanning the skies for radio signals, assuming that any civilization advanced enough to communicate across interstellar distances would be using radio waves just like us. But what if they've moved beyond radio? Imagine for a moment trying to explain the internet to someone living 200 years ago. The concept of sending information instantaneously across the globe via a network of interconnected computers would have seemed like pure magic. Now imagine trying to explain the internet to an ant. The technological gap between us and a hypothetical advanced alien civilization might be even greater than the gap between us and an ant. Their methods of communication might be so sophisticated, so far beyond our current understanding, that we wouldn't even recognize them as artificial. Perhaps they're using forms of energy we haven't even discovered yet, or manipulating space-time in ways we can't even begin to comprehend. Chapter 5. The Simulation Hypothesis. What if everything we perceive as real, the very fabric of our existence, is nothing more than a sophisticated computer simulation? This is the simulation hypothesis, a mind-bending idea that challenges our very understanding of reality. The idea is this. Imagine a civilization so advanced that they possess computing power beyond our wildest dreams. This civilization could create simulations of universes so complex and detailed that the simulated beings within them, us, would be completely unaware of their true nature. Think about the incredible advancements we've made in computing power just in the last few decades. We've gone from room-sized computers that struggled to perform basic calculations to smartphones that fit in our pockets and can process information faster than the human brain. Now, extrapolate that progress thousands, millions, even billions of years into the future. It's not inconceivable that a sufficiently advanced civilization could create simulations that are indistinguishable from reality, at least from the perspective of the beings within the simulation. And if that's the case, how would we ever know? How could we possibly distinguish between base reality and a perfect simulation? Proponents of the simulation hypothesis point to a number of intriguing clues that suggest our universe might be a simulation. For example, the laws of physics seem to be finely tuned for the emergence of life, as if they were programmed into the fabric of the universe itself. Furthermore, the universe appears to be pixelated at the smallest scales, much like a computer screen. And then there's the strange behavior of subatomic particles, which seem to exist in a superposition of states until they are observed, as if the universe is conserving processing power by only rendering what's necessary. Of course, the simulation hypothesis is highly speculative. Outro: the silence persists. The absence of alien contact does not necessarily mean that we are alone. It could simply mean that we are looking in the wrong places, or that the universe is full of civilizations that have come and gone, their stories lost to the vastness of space and time. In the end, the search for answers to the Fermi Paradox is a search for understanding not just about the universe but also about ourselves. If we do find other life forms in the future, it may be a profound moment of connection, but until then, we must continue to explore, learn, and evolve.